Good morning, leaders. And how are you today? You're fine. That's good. There are a few announcements that I still want to make. The first one is you can always download the RU Connected app on your Play Store on your phone, and then you try and log in there. When you log in, you can go to My Courses, and then browse down, you will see Mathematics for Science, and then you can go and just click there, and then you will see some of the material that were posted there. You got it? When it comes to the material, it means your assignments, you find the assignments there. We're supposed to have an assignment each and every Friday. So give you an assignment every Friday, and then Monday I submitted it before 12 midnight. You get it? And the tutorials will be there. And on top of that, you will also find the textbooks that we have. The textbook. Yeah, the textbooks will be there. The textbook that we are using is this laptop. I don't know why it's not connecting to this. I'm still waiting for the guy to help us with that. The textbook we're supposed to use has a bluish color. You're supposed to buy it. Own it. I did not buy. Don't need one. You're supposed to find out.
No, it's not. I'm trying to connect this laptop so that I can project. Okay. Connect it where? Oh, I did this. It's supposed to be that one. It's a written laptop. Thank you. I was trying to locate it, but I couldn't find it. Let me see.
The textbook looks like this. It's the one that you're supposed to buy. You don't afford, which is not unusual. There are two textbooks that are connected that can be used as an alternative, but this is the prescribed textbook. You can use those on connected, just go in there, check the textbook, you can use them. And also I always upload the slides on connected. So if you feel like maybe, because that's what is going to happen in the next few weeks, you will feel like you have a lot, you can always go to the slides, check what we did. You have to attend the classes because not everything that is there, not everything I will say is there on the slide. So at least if you have the class, you have the slides, I think you can do much better, especially if you are also attending the tutorials. Last year, out of 203 students, we got 100% pass rate. And more than 8 do not have a textbook. But if you are serious, you will pass. So that's what happens with the matter of the textbook. Any question on that? Okay. And then another thing is, I think I've covered most of the things except for one thing. When should we start having our assignments? Once we start every Friday. Do you want us to start this Friday or next week Friday? The leaders are not ready. But it's fine. Let's just take a quick recap of what we did yesterday, then we move on. Right. Okay. Yesterday we said that the main idea of this course and why you made it is because you want to be able to analyze data, right? And we had something of that nature. And then we said that if you have two variables, in this course we're only going to deal with two. If you want to deal with multivariate calculus, you should have registered for pure maths. If you are doing computer science and you think that you want to prove things, you should have registered that side, not here. This is the mathematics for biology or life sciences. Right. Of course, we have limited time, so we cannot do everything. We just do the things that are important here. But if you have registered for maths, then we're going to do everything that side. You got it? Yes. And then we said that you have two variables. One we said it is an independent variable. An independent variable, if you are in the lab, is the variable that you control, like time, recording data after every 5 minutes, or after every 1 second, or after every 2 seconds. That's the independent variable. And the dependent variable is the one that you are trying to observe. And then we said that you have to be able to answer these questions in order for you to say that, okay, I've analyzed the data. You got it? And then after that, we said, okay, in order for you to be able to do that, you must be able to know some of the basics, exponents and surds and other things like factorization. Let me just say algebra. You getting it? Yes. And then I gave you these questions and I wanted some answers and you gave me some. Right. Did I give you my answers? Maybe it's because I think that you can find them. Maybe that's why. And then we talked about what is an exponent, power, and the base. And then we looked at the laws. And the most important one was number 4. And we said that that one is always true if this part here, which is the square root of a to the power m, is defined. And also the square root of a is also defined. That's when that is true. If that is not true, we said that whole principle is not satisfied, so it's not correct. That is why it's right there. And then we moved and we talked about rational numbers. Said rational numbers are real numbers first, and they can be written in the fractional form such that the numerator and the denominator are integers. But the denominator is not a 0. And then we talked about irrational numbers. The rational numbers are real numbers that are not rational numbers. Simple as that. And then we said there is something called a surd. We said a surd first just must be an irrational number, then it must be inside some root there. You getting it? In other words, we said that a surd is an irrational number, right? But we do not say that all the irrational numbers are surd. You getting it? So the surd is contained inside irrational numbers. Getting it? And then we moved on, and then we had some laws, and then we said this law is satisfied if this part is satisfied and this part inside is satisfied. Right. And then we have some restrictions and we talked about, okay, n root is always going to be defined. If n is even, if n is odd, it's always going to be defined. But if n is odd, it's always going to be defined. But if n is even, we want what is inside to be positive. You getting it? Or a 0. And then we also talked about this, talking about some of the common mistakes that we usually do. And we said that one of the common mistakes students usually do is to say a square root is plus or minus. And I was trying to emphasize that, the square root is always positive. So the square root of 25 is that? A 5. And then from there, we said that this mistake here of assuming that whenever you have a square root of a squared, you are going to get an a is not true. Because if a is negative here, you're going to get a positive answer after taking the square root, right? But a was negative, so the positive and negative are not the same, right? And then we made this example there. And then one of our students was asking, what usually happens now in the case of, let's say, you have, let me try and see. I don't have a pen at the moment, but I'll see and try if I can write here. What happens in the case of having, let's say you have x squared is equal to 25. Did I say that the rule there is violating this. I did not say that. I just said that. Of course, the answer to this doesn't mean that x is equal to 5. You getting it? But if, let's say, you are trying by all means to make sure that at least you get the sense of what is happening here, all you have to notice here is this. When you are dealing with algebra, what you do on the right, you do it on the left. You don't just come up and say, you have a plus or minus. Where is it coming from, the plus and the minus? Yes, I have a minus. No. The first thing that you'll have to do, I want to make sure that I find the value of x. Right. If I wanted to find the value of x there, I want to remove that power 2 there. You get it? So to do that, one of the things we know is taking the root on both sides. So you're going to take the root on this side, and then you also take the root on this side. I don't see a plus and a minus there. Is it supposed to be there? Yes or no? Where is it coming from? I mean, I just said that I want to take a root on the other side and a root on the other side. Anything that I'm doing on either side, it should be the same on both sides. I get x squared is the same as 25. Why now I will end up having a plus and a minus there? No, I'm not supposed to have. I'm supposed to do one thing and take a pause and see, what am I going to get out of this? And this rule that we have over here, we just said that whenever you are taking the square root or the factor root, let me just say even root, you're supposed to get a positive answer. What is the square root of 25? Yes, so you're going to have your nice 5 there. And a positive 5, just a positive 5, because when you're taking the square root, you're supposed to have a positive answer there. Now, what do you do? Move on. I know that most students don't like moving on. They like to hold on something that is getting them. But move on. From the right hand side, all you have to do, move on. Right. Now, let's deal with the right hand side. Right. Remember that x we don't know. We don't know what the value of x is. Right. Since we don't know the value of x, the answer we're looking for must give us a positive square root. Got it? Yes. It must give us a positive square root. We are done with the right hand side. We're focusing on the left. So let me say this thing is supposed to be a positive x there. Right. It's a positive, that's a plus. If x is positive, the square root of whatever was inside is a positive answer, isn't it so? It is a positive answer. But what if x is negative? Are we going to get a positive answer? Is x going to be positive? What do we need to do to make x, the answer we're getting there, to be positive? Divide by? Thank you very much. My students are very smart. So this minus here is coming there to encounter the case where x is negative. So that if I have a negative x times minus x, you get a positive answer, isn't it so? Even in the case there, we had this minus here. You square it, you get minus 1 squared is a 1. Whenever you're taking a square root, you get a positive answer. But this is not the same as what was inside. Now, how do we make sure that if this thing that was inside gave us a positive answer? Multiply by minus 1 or divide by minus 1. Do you get it? That's where the plus and minus comes out. You getting it? Yes. Now that you have this is saying that positive x is positive x is equal to 5, or minus x is equal to is equal to positive 5. Do you get that? But when you are looking into this part here, and you want to solve for x is just equal to a positive 5. When you're looking for this part and you want to solve for x, you divide by -1, and then you're going to get your x equal to -5. Do you get where this plus or minus comes from? It doesn't just come out of nowhere. It comes from the x on the left, not on the right. Because we don't know what x is. If we knew, we don't need all this information because we can just do what we need to do to get a positive answer. Do you get it? Yes. So most of the time, this is the answer that we usually have, but the information comes from there. You getting it? Yes, madam.
So what I'm getting from this is that since the x is squared, it could either be positive or negative.
Yes.
A negative number is cancelled out by the square.
Yes.
So if it's an even, x is equal to an even number. Is it? Can you please explain that?
If we are saying that we have x to the power 2, we don't know that x is. X can be negative. If x is negative there, raising it to exponent 2 will give us a positive answer, right? Now, we want to find the positive answer, because we have a square root, right? The answer must have is positive. But the answer that we are looking for, we want to write it in terms of the x that is inside there. You getting it? So, when you are having that root inside there, which removes the negative, you say, okay, suppose that x is positive. If x is positive, squaring it will still give us what we were getting inside. Right? So x, we can say x is going to be 5. Fine. But if x is negative now, you squared it to remove that negative. Now we want that negative back. You getting it? So we have a minus x, minus 5, minus 10, minus 100. But the answer we're looking for, we want it to be positive. So how do we make sure that minus 100 is a positive answer? We multiply. That minus is not the minus in x, it's the minus to cancel the negative in x. You getting it? Yes. Minus 5 is fine, it's there inside, but multiplied by minus. Are we all getting that? Yes. Now that we have this nice thing here, how do we make sure that we remove this confusion and misunderstanding? So what we actually do, we define what we call an absolute value. Right? You can just forget for the function at the moment, just take the absolute value. Right? What an absolute value does is saying that if I take the absolute value of a negative, I want to get a positive answer. I have this real number, but this real number I want it to be positive. You got it? You're not getting it? That's a definition. The definition is saying that what is an absolute value? What is an absolute value of 5? Absolute value of 5, the magnitude, I want it to be the same as 5, but I want that to be positive. You get it? So the absolute value of 5 is supposed to be a 5. 5 is positive. But if I have a minus 5, I want to make that minus 5 a positive. Right? Minus 5, to make it positive, I want to multiply by a minus to get a positive 5. You get that piece? Yes, that's what this whole thing is saying. If I have this a inside, and we know that it is positive, the absolute value is going to give us the same answer a. Right? And then if a is greater than or equal to 0, which is positive, or 0. 0 is not positive. Is 0 positive? Is it negative? Just there. 0 is actually causing problems in debates. Let me leave it there for you guys. And then if this is negative, if a is negative, we're going to get a negative answer. To make it positive, we multiply by a negative there. Right? That's what an absolute value is. Now, can we use this? All in. Okay, what do we that? Okay. Now, can we answer your questions? The questions that we had yesterday. Can we? It's not that hard, guys. What we did, these are the questions that we asked. That if you take the square root of a squared divided by a, what are you going to get as long as the denominator is not equal to 0? You getting it? So the first thing that we did is use this definition that we know of, right? And solve these questions. And also this understanding of this, look at this part here, which is the root, the square root of a squared is the same as absolute value. Just wanted to mention that, almost forgot. So it is the same thing. The reason this absolute value thing came up, wanted to remove the confusion of square root of a squared, so that we can have a little different way of rewriting this. You got it? Now, the square root of a squared is the same as absolute value, right? And this a is still the same, is still there. What we are actually doing here, we are actually changing this absolute value to be a if a is positive. Remember that a cannot be 0 in this particular question. So even though we had a greater than or equal to 0, but you can include it there is no penalty. But because a cannot be equal to 0, so I just put a greater than 0. And then we still have this a here, is there. And if a is negative, this is going to be minus a divided by a. And then what is a divided by a? That's where this one is coming from. What is minus a divided by a? Minus 1. So the answers that I expected from you is a plus and a minus 1. That's the correct answer for question number 1. Please write it down. These are the things that we usually make mistakes of. And now when I'm deducting in 5 marks or in the marks that you got, still are complaining, I want to remark it. I mean, this is very good stuff. That's why if you get 90 and you don't get this, I have to minus 5 to get 85. Because this is very tough stuff. You getting it? So make sure that. Guys, is that wrong? Yes. So you are already telling me that you're going to make mistakes in the test and the exam. I can see. Are you all saying the same thing that I'm wrong? Yes. No, I see. This is the 90%. This is the 9% that did not make it the year before last year. I can see. Yes, it's not 9%. Yeah. The 91% is the one that actually made it. Yeah, they do not have a problem with that. You get this? And then the second one is this part here. What is square root minus? The square root of minus 25. What is the square root of minus 25? Undefined. Undefined squared. It's just undefined, guys. Come on. There's no trick here. We're not playing the magic. Undefined. So here you get undefined, and then you square it up, you get undefined. You getting it? So the correct answer for this particular class is undefined. The correct answer for this class is undefined. Right. Now, what if is undefined? That's the correct answer for this class. How do you end up having undefined squared equal? Some people have tricks. But this is undefined. Let's talk about what if you switch those two. Remember yesterday we said that we can switch the power in the root. It doesn't matter which one you can start with. But there was a condition. Only if, when you start with the root, the answer is defined. Only if, whenever you also do you start with the power and then you take the root later, the answer is also defined. That's when you can do that. But in this case, square root of minus 25 is undefined, so you cannot switch anything. You cannot switch anything. You getting it? Hence, I am saying that this cannot happen. That 25. Because if you are taking the square first, you get a positive answer. Taking the square root must always be positive. You're supposed to get a 25. But you can't do that because the root is not defined if you start starting with that is why you are not getting anything if you get a positive 25. Right. Now let's talk about minus 25. Minus 25 is because of bit values. If you have actually done complex analysis, we haven't done complex analysis in this class, we are not planning to. It's for maths people who are actually dealing with imaginal numbers. Imaginal numbers. Imaginal numbers have their own rules, have its own rules. There are so many of them. There's a course for that. I think when you're doing maths, there's a course for that. Someone who has done that will say that, say you are lying, the correct answer is minus 25. Right? Minus 25, yes, because what you actually do, when you're taking the square root of a minus b, you're always going to get an imaginary number. For that case, the imaginary number is going to be 5i. That's the correct answer that we're going to get when you take the square root. Then when you're squaring it up, we're going to get a 25i squared. And you have an I squared. And I is the square root of minus 1, right? So with that, you can actually deal with it. But you will end up getting that answer that is corrected 2 marks. But for us, the answer that I expect is undefined because you haven't done complex analysis, you haven't done anything that is doing imaginary numbers. You getting it? Yes. I don't want us to get confused in between. So undefined is the correct answer. You getting it? Yes. But when someone is too forward and telling you, no, it's minus 25, just say no. No. You get full marks. For this class is full marks and to find. I was just trying to explain to these guys who think they're smarter than me. That's why they end up having that minus 25. You still get full marks, it's fine. But for this class, I'm expecting undefined. Okay. Now the last one is, what is the square of minus 25? Square. Yeah, I think we're also undefined. But it's fine. When you're taking the square of minus 10, you get a positive thing. So the square of minus 25 is 625. And then that's a positive answer. And then you take a square root of that. You're supposed to get a positive answer. The square root is always positive. Look at it. Are you getting that? Yes. Now that you have that, an alternative way, because when you're writing the test, that's why we are revisiting these things. You're supposed to just jump right to what you're supposed to study here, but you're not going to be using a calculator in the test. This is a maths class. So, you have to have all this understanding. When you have a calculator, you can always check the exam, you're not going to have a calculator when you're writing this course. So, an alternative way of dealing with this is this. What did we say about the square root of a square? It's the same as an absolute value, right? What is an absolute value of a minus 25? It's 25. Just in case you didn't know what this answer was, just take the absolute value, you get 25. Full marks. Are you getting it? Yes, ma'am. The power is 3. The third root, or a to the power 3. So what is inside you have? A to the power? Okay. What is going to happen there is this. You have a to the power 3, right? You are taking the root. Let's look into it deeply. Suppose that a is negative. Right? A negative number times a negative number, what do you get? Times a negative number again, what do you get? Can you take a square root of a negative? If a is negative, we will have a negative number inside the root, so we cannot do anything. You get it? So you're going to get undefined divided by a. You get it? Which is just undefined. Sorry. But if a is positive, right? So what are you going to get? A times a times a, you will end up getting a to the power 3 divided by a, right? A to the power 3 divided by a, is that correct or not? Let me rewrite it here. You are saying that we ruled the a being negative, right? Out. It cannot be. We're looking for the positive. So what we are saying, we will end up having, where's this pen? So you're going to end up having the root of a to the power 3 divided by a. This is what you are saying, right? Listen to this. A is positive, right? If a is positive, a to the power 3 is going to be positive, right? Now that you have that, you're going to end up having a to the power 3 divided by 2 all over a. And now you use the laws of exponents. When multiplying powers of the same base, when multiplying powers of the same base, when dividing powers of the same base, we only use the absolute value when you have a square inside the square root. You get it? Not when we have a to the power 2. Thank you, man. We're all getting that. Now that we have this nice thing flowing, yes. C. This number C. You are saying that you want to understand that the square root of minus 25 squared is the same as the absolute value of minus 25, which is the same as 25. Is that what you're asking? Happy? Thank you. Why? What are you saying? Why are we getting that? The absolute value is just there to remove the negative. That's the main goal of it. Just there to just remove the negative. But it happened to be the same as the square root of an a squared, of an x squared. You get it? Define. Identify. You identify it by having a square root of something squared. That's what an absolute value is. Yes, once you have a number squared and you're taking the square root, yeah, that's the same as an absolute value. Happy? Okay. Now that I've messed up my notes, sorry. Okay. Oh, this is messed up. Okay, this is also one of the mistakes we actually have to say. Another question. Now, these are also some of the mistakes you actually make. Students usually assume that square root of a squared plus b squared is equal to a squared plus square root of a. That's not true. The actual answer is these two are not equal, these two are not equal, and these two are not equal. You can try and assume that A is equal to 1, and also assume that B is equal to 1. What is 1 squared? 1 plus 1? Okay. What is 1 squared? What is the square root of 1? Okay. What is 1 squared? Square root of 1? What is 1 plus 1? So the square root of 2 is not equal to 2. You get it? Yes. That's why these things are not true. Can they be true, actually? Now the maths is starting to keep you. If B is equal to 0, if B is equal to 0, what is the square root of 0, guys? Yeah, so you're going to have a 0 here, you're going to have a 0 here, so this will be the same as that. That's the only case. Yes. Okay. Now, I want us to talk about this, and then we'll shut up. So 5 minutes. 4. Okay. Now, what is this thing called rationalization? Right. In order to understand what is a rationalization is, first you have to understand what is a conjugate. Right. A conjugate. Now, suppose that we have a side, and this side of ours is A minus square root B. You know that side there must be some root there. Right. You have that side. When you are changing the sign in between A and square root B, the answer that you are getting is the conjugate of A minus square root B. You getting it? What I'm saying is, this is the conjugate of that. Right. We changed this sign to get that. And this is also a conjugate of that because we changed this sign to get that. You getting it? Okay, thank you. Now that you have that, why is it necessary to have a conjugate? The reason for that is that sometimes, especially when you don't have a calculus, right? You are working with fractions, and these fractions have sides. You want to remove this side somewhere so that your calculations are smoother. That's why you need this, right? And when you're multiplying a side by its conjugate, what you get is a number that is not a side. You get it? Yes, that's why we need that. You will deal with that a lot. Right. Then once you have this nice thing here, okay. Suppose now I have a fraction. And this fraction, the numerator is a side and the denominator is a side. Right? I have a fraction, the numerator is a side, denominator is a side. Take it on this. If I focus on the numerator first, if I take the conjugate of a numerator, I multiply the numerator with that conjugate and also multiply the denominator with the same conjugate. Work my way out and get the answer. Right. That process is said to be, I rationalized the numerator. You get it? If I took the conjugate of the denominator, I multiply the denominator and the numerator, then that is called rationalizing the denominator, right? In general, that process is called rationalization. You get that? It's not that hard. This is a nice example for it. For this, the question is rationalize the denominator, which means focus only on the denominator. Find the conjugate of this, change the sign, we change the sign here, and then we multiply the denominator and the numerator, we work our way, and then we got up to there. You get it? That's what there is to it. And if you have a number that's like this, or a circle like this, all you still do to find the conjugate, you change the sign. Happy? Yes. That's all there is to it. Try and solve these problems and see what you are getting as your homework. If you do not copy everything, I'll upload the slide on Are You Connected. Thank you. Bye-bye.